Right, let's move on to a function. A function is a reusable block of code that you can call separately or repeatedly, I should say, to make calculations, output data, or really do anything that you want. This is one of the key aspects of using a programming language. To add to the built-in functions in Python, you can define your own rather than wait for someone else to define it for you. So if we would take a look at this, so we have defined this function called hello world. All right, if you look at hello world, you have this doc string and you print hello world. Okay, so when you run hello world, it will print hello world. Okay, so hello world here, bracket basically means we are running this function. So here we iterate, rather we use the for loop to repeat it 5 times, and we should print hello world 5 times. Functions are defined with def, a function name, a list of parameters, and a colon. Let me repeat this. It starts with def, function name, okay, list of parameters. In this case, there's nothing in here, and a colon, which is this one here. Everything indented below the colon will be included in the definition of the function. We can have our function do anything you can do with a normal block of code. For example, our hello world function prints a string every time it is called. If we want to keep a value that a function calculates, we can define the function so that it will return the value we want. This is a very important feature of functions, as any variable defined purely within the function will not exist outside it. So if you do this, it will be stuck. Okay, when you run see the scope, nothing. Okay, so let's just run this. When you print this, you will get error. Okay, right. When you run see the scope, nothing. When you print it, you get error. Just so that you can see that they are separate. Let me delete that for a while. Run it, notice it's nothing. So if I paste it back, you get the error again. Right, the scope of a variable is the part of a block of code where the variable is tied to the particular value. Functions in Python have an enclosed scope, making it so that variables defined within them can only be accessed directly within them. If we pass these or those values to a return statement, we can get them out of the function. This makes it so that the function call returns values so that you can store them in variables that have a greater scope. Right, in this case, specifically, including a return statement allows us to keep the string value that we define in the function. Anything you can do, I can do better. So we are returning this function. So my string is storing whatever this print out. So when I print my string, I should get anything you can do, I can do better. And there you go. Just as we get values out of a function, we also put values into a function. We do this by defining our function with parameters. All right, the parameters here is x. Okay, whatever x is being provided, we multiply it by 5 and return it. Okay, running this, n is equal to 4, print n. And we print multiply by 5, n, which is x here, 5 multiplied by 5, and return this 5 times 5 is 25. And when you print this, you should get 25. Oh, sorry, it's a 4. 5 times 4, my apologies. I think I need to go back to primary school. Okay, so in this example, we have one parameter for our function x. We can easily add more parameters, separating everything with a comma. All right, so we define calculate area. So we have length and width, okay, and return a multiplication of the two. So length is given as 5, width is 10. So area is equal to calculate area, which is this function we define here. And length is what? W is what? Print it out, and you get the area, length, and width. The next one is we define a function called calculate the volume. We need the length, width, and depth. Okay, run this function. If we want to, we can define a function so that it makes an arbitrary number of parameters. We tell Python that we want this by using an asterisk. So this is really, we have no idea how many. So this is an arbitrary. Okay. So some value is equal to 0 for I in arguments. We just add them all up. Okay, so however many that you put in here, it would just sum them all up, then return it. Because here is just keep adding them together. So we print them. Okay, sorry, I mean run it. Okay, so the first one is summing 1, 2, 3, and then the rest is the same idea. The more you put, this still the same way to do it. Okay, the time to use asterisk args as a parameters for your function is when you do not know how many values may be passed to it. As in the case of our sum function, the asterisk in this case is the syntax that tells Python that you are going to pass an arbitrary number of parameters into your function. These parameters are stored in the form of a tuple. Okay, we have this function, we have args, print the type of args as in the argument types. You test args, which is this one here, and you put all of these in. It's actually tuple. Okay, we can put as many elements into the argument tuples as we want to when we call the function. However, because args is a tuple, we cannot modify it after it has been created. The arguments, the name of the variable is purely by convention. You could just as easily name your parameters asterisk vars or things. You can treat the args tuples like you would any other tuple, easily accessible. Easily accessing args values and iterate over it as in the above sum values function. Our function can return any data type. This makes it easier, or rather easy for us to create functions that check for conditions that we might want to monitor. We define a function that returns a Boolean value, and this is a coming example. We can easily use this in conjunction with the if statement and other situations that require a Boolean. Definition has a val word. Now the docstring here says check to see whether a word contains a vowel. If it doesn't contain a conventional vowel, it will check for the presence of Y or W. Does not check to see whether those are in the word or in a vowel context. So A, E, O, U. So for vowel in vowel list, okay, if vowel in word, remember this is just a variable, this is an unpacking of this vowel list. Okay, if this vowel A, E, I, O, U is in the word, whatever word that we enter as part of our parameters, return is true. Okay, otherwise return false. Okay, run this. We're gonna put catnapping. If has a vowel, which is this one here, my word, which is catnapping. How surprising, an English word containing a vowel, otherwise this is actually surprising. How surprising. Okay, so that means it has a vowel. Okay, of course it has a vowel. Catnapping has multiple vowels. Okay, so the next one is point marker. You have X and Y, right? Return X and Y. Okay, the above function returns an ordered pair of the input parameters stored as a tuple. Okay, so you have A is equal to point marker, point maker 0, 10, B is point maker 5, 3, calculate the slopes, point A to point B. Okay, so interesting. Point A to point B. All right, good. Let's run this, see if this likes it. Oh, okay, yeah. So anyway, this is the input parameters 1, this is the input parameters 2. Okay, so basically this is actually calculating the actual slope. Print the slope between A and B is this. So calculate slope, this is our input parameters A, B. So when you run it, the slope is -2. And that one calculates the slopes between 2 points. All right, the final one, print the slope intercept form of the line between A and B using point A is Y minus 0 is equal to 2. Okay, so this is input parameter 0, parameter 1, parameter 2, format A1, A0, and calculate the slope. Oh, wow. Interesting. So when you run that, okay, so the slope is, so basically it writes the formula out for you. With the proper syntax, you can define functions to do whatever calculations you want. This makes them an indispensable part of programming in any language, not just Python. All right, the next steps, really there's a lot of information and materials yet to cover. Make sure you play around with the cells in each notebook to accustom yourself to the syntax featured here and to figure out any limitations. If you want to dwell even deeper into the material, refer to the documentation for Python. We are in the process of developing a second part to this Python tutorial, designing to provide you with even more programming language. Keep an eye on the Quantopian lectures page and the forums just by clicking to this link. And that's all for now. Thank you for watching Quantopian lecture series Introduction to Python.